Hello friends, welcome to this video, and this video is a part of YouTube series of data science and machine learning. And those who are interested, those who want to become a data scientist right from the beginner level, also being an expert level, if they want to extend their knowledge, they want to have a hands-on, they want to explore the theory of data science, they want to see the programming of the data science algorithms or the applications. This is the right series for them to watch. Now, in this video, we will see what is a data, how the classifications how classifications can be done. It will also talk about what are the philosophy behind the data representations, the way we make a Excel sheet. So how do we make a Excel sheets? It's not just the opening and writing, but what values we write in the Excel sheet, how did they come? And that's a whole theoretical exploration we are going to do in this video. So the last video we have seen the iris data sets. Okay, so in a iris data sets, just to add up some more information, it has a 150 samples in these iris data sets, and it is available publicly, freely available. Also, it has been included in the scikit-learn machine learning library, which is normally used in a Python. So this data set is nothing but the flower species, and there are the and these flowers, flower category is has a three different species. One is a Setosa, versicolor, and virginica, and those iris flowers will fall in which category is normally done by observing the petal length and width and sepal length and width. So the downward size uh, so the downside there is a sepals, and then upsides of the flower is a petal. And the total number of samples in this data sets are 150, and as there are the three categories, for each category there are the 50 samples. Now if we just consider the sepal length and sepal width, and we plot the graph between the sepal width and sepal length, scatter plot for all the three classes, and this is the red, the yellowish, and then gray colors are the three classes corresponding to the Setosa, versicolor, and virginica. Then we also plotted the data, but now with the three features. Okay, so what is there? There are actually four features available in these data sets: the sepal length, sepal width, and petal length and petal width. So sepal length and sepal width we plotted here. We did not take a petal length and petal width, but it will be interesting to see with that also, right? So of course you have a program, you can just change that. Now you have a out of this four, the two we drawn here, and now here one more case, the three. Now there is no possibility of drawing all the data data with all the four dimensions. Okay, so you might have to repeat that by skipping the sepal length and then considering the sepal width, petal length and petal width, and then you can also draw. So here also 2-3 combinations you can draw. Here also you can draw the combinations and see the data is a I mean the classes are are separate from each others by how they are separate from how the one class is separate from the other class, and so on and so forth. You can see now of course the data plotting will be very important thing. We will have a data also. How Now let us see the what is the the data science or the data philosophy behind the having the data, behind having a classifier or the classes. So let's look at this slide. So normally whenever the classifications or any data analytics application, be it classification or regression or even it is a clustering, the dimension is a very important term. So what is a dimension? It could be a perspective. So one let's say one building I can see from the one direction, and second time I can see from the another direction, and that's how the different perspective, the different observations or different measurement will be taken. It could be objective also. I mean if I want to see the different buildings and I want to see the beautifications of that buildings and their gardens, then it is a kind of the objectives. And different buildings will have a different measure value of building beautifications. Okay, the measure, I mean this is a very simple thing, and this we do, and it's very specific. For example, if we want to measure the height of any person, we put a one tape or the scale, and then we just measure. It is a 5 foot, 8 inch or 9 inch or 11 inch. Okay, we also, if we want to buy rice, we put it on the scale, weighing scale, and we get it. We come to know whether it is a 1 kg or 1.5 kg or 1.2 kg or something. So it's a measures, right? Then the characteristics. So let me take again the same example of the building. Okay, so what is the color of the building, right? So that building is a white, or it is a multiple colors, or it is a red colors, or it is a green color or gray colors. Okay, these are the some of the characteristics. And it's not just the color, it could be sometimes the shape also. Let's say one table. So table can be circular, can be rectangle, can be square also, and can be triangular also, right? So that's the characteristics of that particular thing or particular entity. Now if we have an entity or the sample, we try to map them, and we map them onto the dimensions. So we map them or we project them onto the dimensions. Okay, so so let us see the example of the dimension here. Let's say there is a one entity P&G, which is the kind of the industry. Okay, and this entity, let's say. So this P&G or this entity has been projected on the different 3 dimensions. So one is what the company, what that entity produces, okay, or what that entity deals in, which product category. What is the presence of that company, geographical presence, and then how many employees are working in that company. Okay, so all the 3, that means if the Procter and Gamble company has been mapped or projected onto these 3 dimensions, the product category dimension will give a value FMCG, because it's a fast moving consumer goods it's produce. Its presence is a global, okay, it is all over the world, and if they have an employee, let's say, I don't know the exact number, but let's call it as a 1 million, 10 lakhs. Okay, so once we have a entity, we mapped them or projected them in, we projected that onto a 3 dimensions, and we got a 3 values, and this is called as a vector. Okay, this dimension can also be called as a feature. Now these dimensions forms a vector, and then vector can be called as a vector itself, or feature vector, or feature representation. And nowadays, because of the natural language processing, some word embedding, even the embedding is a word people are, or data scientists are using to denote this vector. Okay, so let's move on to next slides. So now here we will see the dimension separability. So we have a, let's say now we know if the sum of the entity is given, then we have to decide which are the dimensions or the features we are interested in. Once we decided that, we can map that entity onto those dimensions, and each dimension mapping will give a value, and all the values obtained from the multiple dimensions will form a vector, and that will be the representation of that particular entity. So here Procter & Gamble is a vector sorry, Procter & Gamble is an entity formed by values FMCG global and 1.5 millions. Okay, now HLL, Hindustan Lever, so it is FMCG, it is again the global, and it has a, let's say it has a 1 million employees. Now Patanjali, it is FMCG, it is a country based, it is a it has a employees 200k, means 2 lakhs. Okay, these are the 10 lakhs and these are the 15 lakhs. Okay, now if we draw these 3 samples with these 3 dimensions, so the one is the number of employee dimension, another is a presence. So if it has a presence at the very least number of places, that means the country level, so it will come here, and as it has a global presence, it will go upward. Now what it products, so we will just tick them on the different categories. But in this problem, all the 3 companies are the FMCG, so this data we can ignore. Now if we try to draw so we have a Procter & Gamble, HLL and Patanjali, and their Procter & Gamble is a square, HLL is a circle, and Patanjali is a triangle, and we try to plot on those 3 dimensions over here. So why triangle is over here? But because number of employees are 2 lakhs as compared to 15 lakhs and 10 lakhs. Okay, so on this dimension, so it is close to the 0, right, to 2 lakhs, and this is kind of a 10 lakhs, and this is kind of a 15 lakhs. Okay, the graph is not exactly to the scale, so just it's a graphical representation and relative one. Now if the Procter & Gamble, it is a 1 lakh and it is a global, so global means it will go in a higher values on this dimension, the presence, and that's why it is here. And employees, number of employees will be more than this 2 lakhs, that means the 10 lakhs it has, so it is coming here. And then again the HLL has the same kind of presence, and that is why on this dimension it has the same value nearly same as Procter & Gamble, and but number of employees are slightly higher, so it's a 1.5 million, that means 15 lakhs. Fine, so we have plot this, and now let us try to have a separability. Now can we separate out here this and this? We can separate out with this way, okay, this line or this line, and that is why here you can see the two green lines. So two green lines can separate, even not necessarily all the both the two lines, but even the one line is enough for separating the Procter and Gamble and HLL versus Patanjali. Okay, but if it comes to separate out the Procter and Gamble from the HLL or Procter and Gamble versus HLL, then this is the red line. So these are the kind of the line of separability. Okay, this shows you the line of separability. So when Patanjali versus P&G or the HLL, then you have a two dimensions. On the two dimensions you can separate them out. When it comes to compare the Procter and Gamble and HLL, you have a one dimension, this dimension, that is number of employees, to separate them out from each other. Okay, so Procter and Gamble versus HLL are separable in one dimension, that is third one is the number of employees, which is a, okay, so that line of separability is a line, red line. And Procter and Gamble or HLL combinedly versus Patanjali, and then they are separable in the two dimensions. The one is number of employees and another is the presence, whether it is a global or the country or local, and that's a green line. Now you can see that any data or any entity will or the samples, okay, that will have a dimensions. And let's say if it has only one dimensions, the earlier example we have seen Procter and Gamble, HLL and Patanjali, we projected them onto the three dimensions, but there could be some examples where only one dimensions we are interested in, or we will have only one dimension to represent those data. Let's say the age of the people, and we want to separate out whether they are the young or the old. And let's say, so to decide, let's say 25 we will keep as a threshold. So below 25 or equal to 25 young people, and above 25 they are the old people, right? So the data is on the one dimension, and decision boundary is a kind of 25, so it is a one constant one. Okay, it is a constant one. Now when you have a two-dimension data, let's say there are these are the students who have scored who has a exam 2 score and exam 1 score. So normally it is a subject 1 and subject 2 score. So if we plot them here, then it has a classes. The one is a not admitted to the, I mean this may be the two exams in a engineering entrance exam. So there are two entrance exams, two subjects entrance exams. So and then after getting those marks, which students was admitted into the engineering and which could not be admitted into. Okay, so the crosses means they could not get admitted into the engineering, but these blue circles one are the admitted into the engineering. And you can see somebody has a 80, but another subject in a one subject they have around 80, but he or she hasn't got she has got a very less marks in another subjects, and that's why could not enter. There could be another reason also, because sometimes even you get a less marks, but because of the management quota or some other quotas they might get admissions. So but anyway, we are not interested in what is the reason they got admitted or they could not be admitted, but we have a data of the students who have been admitted, who have got admission into the engineering and who have not got a admission into the engineering. Okay, so this is now if you try to plot the line, okay, what you can do, you can have a line to separate these two things. You can have a one line to separate of this. So somebody has managed to draw this line so that above this line or this side of this line, whichever the data comes is called as a got into the admission, okay, got into the engineering, right? And this side of the line, they will be called as a not got into the engineering. Okay, so this is the decision boundary. This line is a decision boundary. You can see, even though we got this line, but still some of the crosses, that means who were not got admission into the engineering, they have also come to the another side. Okay, and similarly who have got into engineering, they have come to the this side of the, that means the wrong side of the line. Okay, so there will be the misclassification. So anyway, whenever we get a let's say this is the data we have so far in a history, that means up to 2020, the engineering admissions we got it, and now in a 2021 the admission process is going on, and then we want to just see the predict that whether this student will get into admitted or not admitted even before the admission process starts. So that kind of the game we can make out here, but that is how the prediction will be. That is how even the engineering application or industrial application or real life applications, we are going to have a predictions even before the things happens, right? So what is the objective of this slide is, when you have a one dimensions, you have to have a decision point here which is a constant. When you have a two-dimension data, you have a decision boundary as a line, okay? And when you have a 3D data, you can see, so I think you can plot this way with the different colors, but also if you see with the in this particular representation, so this is a three-dimensional data, feature 2, feature 1 and feature 3, and this who has this ponytail, they are actually one class, and the one which have these three hairs, okay, they are actually the another class. So if we plot these two classes points on in this three-dimensional space, we can have a, now if you have a three-dimensional, so you have to have a two-dimensional plane. You have to have a two-dimensional plane. One-dimensional line will not be useful here to have a decision boundary to separate the two classes. Okay, so that's what the objective of these slides and these discussions. So let me conclude this video.